Hey guys, Martin Kosic here. Today I'm going to be teaching you a lesson on chain rule. But before that, I'd like to just do some review of power rule and taking derivatives of linear functions. So we know, before we go into chain rule, we need to review what we knew before. So we all know how to take the derivative of something like 2x squared plus 3. So this will be our f of x. And we know that we need to bring our 2 down and multiply it here to create 4x. And it'll always be n minus 1. So whatever this number is, minus 1 will be the power that's remaining. So this will be a 1. And since 3 has no power, we'll disregard it. So our f prime of x will be 4x. And another example we can do here could be our f of x is equal to 5x cubed plus 6x squared plus 8. So we bring this down and multiply with the coefficient to make that 15x n minus 1. So we have a square here. Plus our 2 coming down to make, that will be 12x and then minus 1. So this will be 12x. And we forget about the 8. And this becomes our f prime of x. Okay, now to move on to the new stuff, the interesting and fun chain rule. So this is an important rule for differentiating functions that are known as compound functions. And a compound function is defined as a function whose values are found from applying one function to the result of another. And they're usually seen in the form f of x is equal to g of h of x. So this is our compound function. So we have two functions here. Our outer function g of x, which is these two brackets in the g, and our inner function h of x. So it's this outer function g acting on the result of the inner function h and our variable x here. And now to take the prime of this, we need to do something called chain rule. And it's actually quite simple if you think about it. What it really does involve is taking the prime of the outside and multiplying it by the prime of the inside. Very simple, so I'll just explain it to you using this generic form. So f prime of x here will be our outer function. We know our outer function is just this. This is our outer function, right? This is what constitutes our outer function. And we have whatever in here, h of x, 5x plus 9, 14x cubed, whatever. Anything that's in there. In this case, we have h of x. So we'll keep our h of x inside, and all we need to do is take the prime of the outside, in which in this case, all we need to do is take the prime of the outside. So we have g prime of h of x, or whatever our interior function might be. And now to complete the chain rule, we must multiply by the prime of the inside. So h prime of x. Very simple. It's just like this. And through all the questions we'll be doing today, as I explain, I'll make sure to clearly identify the g and the h of x, just so you can refer back to this and easily understand what we're working forward through. So our first thing we're going to do is the very easy, one of the very easy questions, a linear function inside of a power function. So for this example, our f of x is going to equal, where are we now? 4x plus 9 cubed. So we can define our g of x here. Now I know this isn't exactly proper notation, but we know that it's just these two brackets and the cube on the outside. And we know what's in here, so I'm just going to put a dash through there. And we know that's the inside of this, multiplied by our h of x, h prime of x, which we're going to define our h of x here to be the inside. We know it right here. It's 4x plus 9. So we can now take our f prime of x, which you'd see here. So we know this is our g prime. So we must take the prime of that. How do we do that? The prime of this looks like we bring the 3 down, right? And we have our brackets with whatever inside. And then this becomes n minus 1, so we'll have a 2 up here. So we have now 3 here, right? We're bringing this 3 down again. And we know we have our h of x inside. So we've defined this dash represents the h of x. Probably should have wrote it inside, but here we go. So now we'll write our 4x plus 9 in here. close our bracket, and we know we have a square here because of the n-1 rule in our power rule. And so there we go. And there's the first term of our chain rule. Now, simply enough, we go and we multiply it by the prime of this. So how do we take the prime of this? We take this thing down and we go n-1, so we know it'll just be 4. And we disregard the 9 because there's nothing up here and there's nothing to bring down. And 0 minus 1 is negative 1 and whatever. So that's it. Well, 1 minus 1 is actually 0, and anything to the power of 0 is gone. So there we are. And we'll have a 4 here. And to simplify this, we can multiply the 3 and the 4 to create 12. And then we'll have 4x plus 9, our h of x on the inside, which you do not take the prime of because it's inside of the g of x, as we can see right here. And we'll have a square. And this is how we take our f prime of x. It looks like I'm running out of paper here. I may have to grab a notebook in a second, but we'll use this for now. So I'm just going to put this underneath here so we're not... okay, maybe I won't. Anyway, so another example, we can do another quick, easy linear function. Just making sure that it's not getting on the table. Okay, so we'll do another quick, easy linear function. But this time we'll have a coefficient on the outside. So plain and simple, we're identifying our g of x to be 3 times our h of x on the inside, which we can see up here and we'll define in a second, to the power of 4. And we call our h of x 6x cubed plus 5x. So there's your inside and your outside. So now you have those both readily available to you. And so we can now try and take our f prime. So f prime of x, right? So we can bring this 4 down and multiply it by, so we're first taking the prime of g of x with h of x on the interior. Remember, just a quick side note to keep you guys informed, our f of x looks like g of h of x, and our f prime of x is going to look like g prime of h of x multiplied by h prime of x. So now we're going to take our g prime first. So we can see our h of x remains in here. And so we're going to go 3 times 4 will give us 12 on the outside. We're going to plug our h of x inside, 6x cubed plus 5x. And we know the property of the power rule where this becomes n-1. So 4 minus 1 will give us 3 on the top. And this is the first term of our chain rule. And then we'll be multiplying by the inner term, h of x, the prime of h of x. So we know that you bring the 3 down and we multiply by 6, giving us 18. X 3 minus 1 is squared plus 5 times 1, and we get rid of the x because we've got a power of 1. And this is our term. There's your f prime of x. Pretty easy, right? Once you get down to it. So here's a slightly different example, still quite important. We sometimes, more often, well actually quite often, we'll see square root functions, such as square root of 3x squared plus 1. Now, this is just like a regular, it's like any other composite function. So it is a power on the outside, and then another linear on the inside. So what it looks like, well, quadratic in this case on the inside. So we can transform this into 3x squared plus 1 to the power of 1/2. And this makes it a lot easier to look at and a lot easier to act and use our chain rule on. So we can start by identifying our g of x, which is going to be these brackets, and the 1/2 on the outside with an h of x in here. And we can identify our h of x, which we know is going to be this inner term, this inner quadratic, 3x squared plus 1. Awesome. So now we can try and take our f prime. So our f prime of x is right there. And so our g prime first, we'll bring the 1/2 down. So we'll have 1/2 h of x on the inside, 3x squared plus 1. Okay, close that bracket. 1/2 minus 1 will give us negative 1/2 here. Okay, and there's the first term of our chain rule. We'll then multiply this by h prime of x. The 2 will come down to multiply with 3 to give us 6. And the x will go. And 2 minus 1 is 1, and we don't need to show that. And 1 will disappear because it'll no longer have a power that's recognizable. So there's our f prime of x of our square root function. I know it's intimidating to look at first, but you just need to transform it into a power, and then it's very easy to enact chain rule on. Okay, so I'm going to grab a notebook here, as I've run out of paper, and we will continue to do some more examples. So another important example that needs to be done is a chain rule. Let's see how badly that bleeds. Oh, it's not terrible. Chain rule with a very complex quadratic on the inside. So if you have something like this, it's very important to be organized, and this method that I'm teaching you becomes much more useful actually in this way. So by identifying your g of x and h of x, you can take primes of them separately and not have to worry so much about doing stuff on the fly as you go. So first we'll identify our g of x, which we know to be these outer brackets, and this 6 up here with our h of x on the inside. And then we can identify our h of x right here to be this long inner function. Now, an easy way to move forward through here is to actually just take the prime of this function immediately. So we can just get our h prime right here, and then we can avoid thinking about it later when we're doing our chain rule. So we'll bring the 3 down from the x. 3 minus 1 will give us 2. Minus 4 times 2, which will give us 8x plus 3. So now we have our h prime. And so now we're all set to take our f prime of x. So we'll go f prime of x. How would I do it on another line? Let's give it a little more space. F prime of x is equal to, so we can see our g prime is identified here. So we got to pull the 6 down, close this, put our h of x inside, which we can see right here. Will give us x cubed minus 4x squared plus 3x plus 2. We see a 6 here, and we need to do n minus 1. So this will give us 6 minus 1 will give us 5. Multiplied by h prime of x, which we've already done here, and we've avoided taking the time to do now. So we can just quickly write in 3x squared minus 8x plus 3. Very important that this is in brackets. So there you go. So that's a much easier way using a method that's very available, just a quicker and more organized way of doing a chain rule here. And once you get into longer chain rules, it's very important to stay organized. So I always find that it's very crucial to write big and to really use the space that you have available to you to keep your notes extremely organized. Now we're going to combine, building on the stuff that we just learned. It's time to combine our power and chain rules. Sorry, not power, but product rule and chain rule to solve a much more difficult problem, something of the next level that you guys will be exposed to. Sorry. So, quick review of power rule. We know if we have f of x equal to, let's say 4x squared multiplied by 6x cubed plus 5x, we know that our f prime of x will look like, we'll label this a and we'll label this b. This function right here, this is b, and this function right here, this is a. Okay, so we'll know this will look like a prime b plus b prime a, right? That's how we know that function is going to look like. So f prime here I'll just do this very quickly, just so you guys just get a little rehearsal. So the prime of this will be 8x times b here, which will be 6x cubed plus 5x. Can you guys still see that? Yeah, that's fine. Plus b prime here, which will be 6 times 3, 18, x squared, b prime plus 5, b prime times a, which is now here, 4x squared. So that's just a quick reminder on how to do product rule. So this is how we will be combining it with chain rule. Okay, let's move that out of the way. All right, so the example I've written up for you guys is, perhaps we'll do this on actually a new page. So here we have f of x equal to 4x times x plus 1 squared. Fairly easy function, but we know that there's a product rule involved there. So, just like we had labeled our a and b functions earlier, it's important to do that now. So we'll call our 4x a. How about we do this a little more systematically? So we'll label 4x to be a, and we'll label x plus 1 squared to be b. Now, before we can do this, what I like to do, especially when I'm using chain rule, when chain rule is involved in my product rule, I like to find the primes of both a and b and have them written on the page so I can just plug them into my equation. So we can call, we know a prime to be 4. And now we need to enact our product rule on this, so we can find b prime to be, so our g of x is here on the outside, we bring the 2 down, x plus 1, right? So there's nothing else up top, times the inside, and actually, luckily for us, the prime of the inside here is just going to equal 1, and so we can forget about it. So we know our b prime is equal to 2x plus 1. Awesome. So now we know both our a and our a prime, and our b prime. So for our f prime of x, we know that it looks like a prime b plus b prime a. So now it's easy enough for us to plug it in and say f prime of x is equal to a prime, 4, times b, x plus 1 squared, plus b prime, which will be 2x plus 1, a, times 4x. To simplify, we can go 4x plus 1 squared plus 8x x plus 1. We can even factor out an x plus 1 if we wanted to, but I don't think it's necessary in this case. So this is how we combine our chain rule and our product rule into one handy little thing here. So again, I cannot stress how important it is to be neat with your work, because that will really allow you to reference things, look back, check your work, and really understand what you've done wrong if you catch a mistake. It's also important to break it down into many steps and clearly establish your A and B. So make sure, again, you're just writing stuff down and staying neat, and use all the space available to you. So today we've learned how to differentiate composite functions using the chain rule, and I'll just redefine a composite function. So a composite function is a function whose values are found from applying one function to the result of another, usually seen in the form f of x. So the form f of x is equal to g of h of x. So there's your composite function form. And so we've learned how to differentiate these today. So just remember, be neat, use your space, and remember the general form. And the general form for the prime here, I'll just review it for you one last time. F prime of x is going to equal to g prime of h of x, so the prime of our outer function, times, with the prime of our inner function there, no prime here, sorry, times the prime of our outer function, h prime of x. So there's your, and then this is the prime here. Thank you guys. This has been Martin Kosic. I appreciate you listening to my lesson, and have a great day. Thank you.